Okie dokie. So let's get rolling. We're gonna start off. Shut up. We're gonna start off by talking about the midterm exam. Um, as a whole, grades were pretty decent. I know this might be a little small, but here I can. All right, so average grade was 74%, and that was actually with a zero. Um, one person didn't take it, so average grade was actually probably slightly higher. Median was an 80. Um, actual breakdown, we had 8 people who had A's, 7 people who had B's, 3 people with C's, 3 people with D's, 4 people with D minus minuses. And then some very bad grades, some 30 somethings, and this was the zero I presume. So really, 2 of you, if you're in this 30 to 39% range, really ask yourself, what's going on? Did you not prepare for the exam enough, or things just not clicking for you? What could you do different for the second 8 weeks? Like I said, programming is hard, and if you're not putting in the reps and the homework, maybe you're believing me a little bit more now that the homework's going to take you more time in a class like this than it will in other classes, and it might not seem fair. It's not my fault. It's topic. Yeah, you got to put in the time for it. I promise you, I'm giving you pretty easy assignments, relatively speaking. They're going to get much broader. You're going to keep spending about the same amount of time, and you're going to go back and say, well, this would have taken me infinity time to do the first time around or something. So, but hopefully this convinces some of you that are in this 30 to 39 range to ask some questions. Did you put the effort in? How much time were you spending on your assignments? Did you turn in the assignments? Yada, yada, yada. I'm not necessarily encouraging anybody to drop, but whole reason I have the policy of, if you bomb the midterm and you do better in the final, I'll replace what you get in the midterm with what you got in the final. The reason I have that policy is for this very reason. Sometimes these people turn out to be the straight A students. Just hasn't clicked for them yet, but hopefully this scares you enough to at least ask the question. If you're on the lower end of this up here, the 50 to 59, ask yourself those same questions, but maybe be a little bit less concerned. Certainly if you're in the 80 plus range, I think you're right where you need to be. Chances are you missed points for a stupid mistake or something like that, or a topic that once we go over today, or if you saw in the feedback on the exams, you're like, oh, I get it. And that would have been the difference between an 86 and a 93 or something like that. Okay, so as a whole, I think the exam went pretty well, like I said. Lots of decent grades. So let's go through it relatively quickly, so then we can get on to some of our other things. So let's see. Oh, I guess I can just begin to take the exam. All right. What does it mean for C++ to be strongly typed and compiled? Well, C++ is strongly typed because you have to put the kind of value that a variable will hold in front of the variable when you define it. That's what it means to be strongly typed. The language requires you to specify the kind of value that lives inside of a variable. What does it mean for it to be compiled? Means that we write it through a compiler, which translates from high level code to low level code prior to running the program. Okay, this is as opposed to an interpreted language where that happens while the program is running. So you could have said something like, compiled languages also tend to be faster, yada, yada, yada. All that stuff is fine, but the core of what I was looking for is what I just said. Strongly typed languages make you define the kind of value variables are meant to hold. And compiled languages are languages that have to go through a compiler, which translates it from high level to low level before you run the program. All right, questions on that one? All right, next one, convert. Here, I'll just copy this here. And we're going from binary to decimal on this dude. All right. So remember, this is the ones place, the twos, the fours, the eights, the 16s, the 32s, the 64s, the 128s. So this is 128 plus 0 times 64 plus 0 times 32 plus 16 plus 8 plus 4 plus 1. 157. So we always start when we're dealing with this pattern, we start at the far right side. This is always the ones place. It's the base to the 0th place. Since this is binary, this is 2 to the 0th place, which is a 1. This was hexadecimal, would be 16 to the 0th place, which is also 1 to the 0 power, which is 1. All right. So 1's place times 2 is 2's place times 2 is 4's place, so on and so forth. Questions on that one? All right. 1328 from decimal to hex. So this tested whether you knew the other pattern with the little twist about the A through F thingy. So 1328 decimal to hex. So this is the one where we divide over and over and over again. So 1328 divided by 16. 1328 divided by 16 gives me an 83 with a remainder of 0, because 83 times 16 is 1328. 83 divided by 16 gives me a 5. 5 times 16 is 80, so I have a remainder of 3. 5 divided by 16 is 0. 16 goes into 5 0 times with a remainder of 5. We read our answer from bottom up, so this is 530. All right, questions about that one? Okay, and these were the important ones for you to show work. I think in general, the class did fairly well on these. If I remember the quiz we had over this stuff, I think the class did extremely well, which is not a common thing. So that means you, as a group, you guys studied pretty well for that quiz, which translated well into the exam. I think the points that were lost typically were like a stupid math mistake, and as long as you showed me the work, you got like a 9 out of 10 or something, like, you know, whatever. It's, you knew what you were doing, but you just didn't quite do whatever perfectly or close to perfect. All right. Write the necessary code to display all the odd numbers. Well, here, it'll be easier for me to read in this font too. Well, not with this blocking. Write the necessary code to display all of the odd numbers between 1 and 100,000 to the screen. All right. Now, first of all, I said write the necessary code. You can come in. You're not going to bother me. You're fine. A drop and give me 50. Did you hurt yourself? Yeah. Like just now? No. Oh. It's in a rush to class. He zigged when he should have zagged. All right, so I'm asking you to write the necessary code. You could have written it in a function if you wanted to, but I didn't ask you for a function. So a couple of things, if you're looking for themes on this exam, and I told you about it ahead of time, is know how to write a function. Specifically, and I harped on this, I had even when we were reviewing for the exam, know the difference between when I ask you to return a value versus display a value. And those came into play in two of the other questions. But this one's just asking me to write some code that displays some stuff, specifically what stuff, the odd numbers between 1 and 100,000. Now, you could have interpreted this a little different, whether you include 1 in 100,000, that didn't really matter to me. But, something along the lines of for int I is equal to, well, this is good. I'll make this bigger. Is it actually bigger? For int I is equal to 0, I is less than, I said what, 100,000? I plus plus, and I'll start this off at 1. So you could have started off at 1 and gone to less than or equal to 100,000 if you wanted to. Now, some people went through every single number and asked the question, is this an odd number? Because we're only supposed to display the odds. So you could have thrown in a question like, if I mod 2 is equal to 1, then that means we're supposed to display it. So we would do something like a C out I and like that. The other thing you could have done is you could have added 2 to this number and just kind of hop through it 2 steps at a time. So you could have said I is equal to I plus 2, and then you would only need to do the C out dealy thing here. So this would go to 1, to 3, to 5, to 7. You'd hit all the odd numbers. All right, questions about that one? Go ahead.
These coding ones do like all the stuff above, like me, just like.
Well, like for instance, this one just says write the necessary code to display this. So, I mean, I would say no, but if you did, it's not wrong. Yeah. I would say any sort of legal code for this one would have been fine. When you get into the functions, I don't need main and all that, but I did need you to write a function that had the right return type and the right parameters and that stuff. How does C++ represent the following ways humans solve problems? Memory, asking questions, and repetition. This was something we talked about a bunch of times, right? So memory is equal to variables. Asking questions is equal to if statements, conditionals, and repetition is equal to loops and functions if you want, but if you just said loops, that's fine. So 100% of programming languages, including C++, has facilities for representing these 3 things: how human beings solve problems, memory through variables, asking questions through if statements, repetition through loops and functions. All right. I think we have that slide repeated a couple of different times, and we've said it in class a whole bunch of times. So surprising number of people, not a whole, maybe like five or 6 people, it felt like, got this one completely wrong. Like you just babbled for like a paragraph about stuff that was unrelated when I gave you half of it in the question. So I was pretty bad. So I guess whatever. All right, next one, write a function. So right off the bat, you're going to be writing a function that has rules associated with it. You're going to need a return type. You're going to need parameters. That takes a string as a parameter, and it returns the number of spaces in that string. All right, so so it's going to return a value, not display a value, return a value. And the kind of value it's going to return is the number of spaces. So that's going to be an integer, a count. So we're going to have an int that it's going to return. We call this guy count spaces, something like that. It's going to take a string as a parameter. All right. Now we want to go through every single character of that string. Ask, are you a space? If you are, we're going to add 1 to some sort of running count. So we're going to need a count that starts off at 0. We haven't found any spaces yet. We have our for loop for int I is equal to 0. I is less than s dot length. I plus plus. So this was your chance to show me that you knew how to write a loop that gets you through every character of a string. Then we'll ask the question, if s at bucket I, if the current character I'm looking at is equivalent to the character space. All right, common mistake that was made on here, that if you got everything else right, I didn't take off points, but I probably gave you a little suggestion in the thing. Some of you wrote that double quote space double quote. That is the string containing a space. That is not a primitive type. The equivalence operator won't work on that the way you want it to work on that. It does not compare strings the way you want it to work. It actually compares memory addresses. I think, did I look at that in class? Show you that? But it'll pop up at another time. But in any case, this would not be correct. You're not asking whether this char is equivalent to this string. We want to know, is the char I'm currently looking at the same char as the char version of a space? Single quote, space, single quote. That's how we represent chars. If that is true, then what do? We say count plus plus. After we're done with going through our for loop here, we've checked every single character in our string. For each one we asked, are you a space? Every single time that was a true, we added one to count. In the end, we're going to return count. Not display it, we're returning it. Okay. Now, what some people did is they displayed it and returned it. Now, that could go two ways, right? It could mean that, oh, I was just making sure I had the right answer or whatever. It could also mean that you didn't really know how to answer the question, so you just covered your bases and did both. I think mostly I probably just gave you the credit, but I wrote something in the comments. Depending on what time of night it was, I may have been more or less belligerent. All right. Questions about that one? And again, I had mentioned this probably even the first week of class when I talked about how homework's practice for the big game. That's why I grade homework pretty easily. And you get to the exams and I grade these, I don't grade these more difficult necessarily, but I look at these much more closely. And one of the things I said is, it's usually pretty obvious whether somebody mostly understands what's going on. I kind of grade for competence or pretty much doesn't know what's going on. So most of the class did well on the exam. Most of you had fairly competent code. Even if you made a couple of mistakes here and there, it was fairly competent. Those of you who were on that lower side, you probably noticed you left coding questions blank, or you might as well have left them blank. You know, sometimes you would just like regurgitate something you memorized that wasn't even related to the question being asked. That's where you start needing to be concerned about whether or not A, is this major for you, or B, have you been putting in the effort you need to put into it? All right, because I don't want any of you to fail. Okay, but you know, if you got a 30% on the exam, you know, you're not setting yourself up real great. All right, so that's that one. Write a function. So again, we're writing a function that takes a string as a parameter and prints every other character in the string to the screen. Okay, so we're going to write a function that takes a string and it's going to display some stuff. So the return type for my function is going to be void. Let's say display alternates. This guy will take a string S as a parameter or whatever you want to call it. All right, we're going to write a for loop here. For I is equal to 0, I is less than S dot length, I plus plus. All right, so now we want to print every other character in the string. All right, so that means we don't want to do every character in the string. We want to hop through our string by twos. That gets us bucket 0, then bucket 2, then bucket 4, so on and so forth. And then we want to print out S at bucket I If you want to kick it down a line each time, that's fine. Up to you. I didn't care if it was right next to each other. I think I kind of gave you an example like it was right next to each other. So if you follow the example exactly, you would have done something like that. Then after the for loop, you would have done something like that to just kick it down a line. Okay, but this goes through every character of a string, hops by 2, prints out the H, plus 2 is the L, plus 2 is the O. And we're displaying it, not returning anything, so our return type is void. Make sense? All right, questions on that one? All right, next one, asking you what the following function does. And I had mentioned in class there was going to be a question like this. And I said, I'm not asking you to go through line by line telling me that, this defines a function. This is a for loop. I want to know, what does the code accomplish? Okay, so I'm asking you, can you read code and tell me what it's doing? All right, so function called do something, it's taking in an int. So we're operating on an int here. We have a for loop that's going through, starting I off at 2, going all the way up to, but not including the integer that was passed in. Each time through, we're asking the question, is the integer that was passed in evenly divisible by the current value of I? If it is, we're going to return false. So you could have said something like, it checks every value between 2 and num minus 1 to see if any of them evenly divide the value. So it returns false if any one of those evenly divides it, and true otherwise. Or you could have taken it a step further and said, this tests whether num is prime. Something like that. A prime number is a number that's only divisible by itself in 1. So anything that kind of let me know that you understood as a whole what this code is trying to accomplish, whether you recognized it was a test for primality or not, less important, because you already know what modulus does and you were looking for things that evenly divide it. All right, questions on that one? Write a function. So again, writing a function that takes 2 integers and returns the larger of the 2 integers. Okay, so we're returning whichever int is bigger. So we're returning an int. And again, we are returning a value, not displaying the larger of the 2 values. Okay, so let's call this guy find max. I'm going to take in an int A and an int B, let's say. So we're going to say if A is bigger than B, return A. It must be the bigger value. You didn't need the else here, but yeah, certainly didn't hurt anything. Else return B. Okay, now I know some of you decided you're gonna return a -1 if they were equal or something like that. Well, what if one of the numbers had been -1? That would have been maybe a problem, but not a problem as long as you gave me roughly the logic of testing one value versus the other. I intended it for it to be roughly this, but if you took some liberties on what do I do when they're equal, that's okay. All right, makes some sense? Questions on this one? All right. All right. So finally, now would you agree that up to this point, all of the programming questions have been relatively trivial, right? Didn't mean that you found it easy, but these were not long drawn out epic adventures, right? Okay. I was testing whether you had some problem solving skills given that you were under a time constraint. All right, so this last one pushes you a little bit farther, right? Kind of shows that as we got into some of the more complex assignments that you were still keeping up. All right, so write a function that's going to take a char as a parameter, and it's going to return something. What's it going to return? It's going to return the numeric equivalent of that char. So it's going to return a number. So before we go on here, let's go ahead and write, it's going to return an int. Let's do hex. Well, I really call them hextets. I'll talk about that. Hextet to num. And it's going to take a char as a parameter. All right. So this guy's return the numeric equivalent of that char out of the collection of hextets. Remember, hextets are the values of the hexadecimal numbering system. So that's 0 through 9 and A through F. And I gave you, even if you didn't understand the word hextet, I gave you a bunch of examples. That is to say, if you brought in the char 0, it would return the number 0. The char 9 would return the number 9. The char F would return the number 15. Make sense? So this question did not necessarily rely on you understanding the word hextet. Hopefully with the example, you connected all the dots there. All right, so we need to do a mapping between a char and a number. Okay, if you remember from class, we had a function like, well, we had to create a string map, and this guy was filled up with those are all the hextets, let's say. Now, I had told you that you could assume that there's an index of function, and you could use that as part of the exam, or you could have just written it yourself. So I'll go ahead and just write it real quick. So we could have a int index of I'll just steal that guy to have him work on that particular string. Well, whatever. This is fine. This is good enough. And then I'm just going to loop through that string for int I is equal to 0. I is less than map dot length I plus plus. If map at bucket I is equivalent to the character you passed in, return I, the place we found it. If we've already checked every single thing, we had our index of return a -1. That's how index of worked. All right. So if I pass a char in here, it's going to return an int. It's going to go through all of the hextets, looking in here for this guy. And if I find the same thing, return the position it found it. It'll find the char 0, it'll find at position 0. The char 9, it'll find at position 9. The char F, it'll find at position 15. Okay. So as much as we wrote it up there, you could have just returned index of C, and that's going to give you the right number there. Or you could have just named this guy hextet to num. That's really all the logic. Some of you assume there was already an index of function that took in a string and a char, where you could pass it any string. So what you did is you passed it the string 0 to 9, A through F, and then the char you were looking for you made the assumption that we had already written it, which I had told you leading up to the exam that you could do. If you wanted to assume index of already existed. But several of you wrote it like this, whatever, shouldn't have been a major ordeal. All right, questions on that one? So that one was a step up in complexity, but definitely represented several different times in recent assignments and things like that, right? All right. Is that it? It's all of them. All right, so that's the whole exam. Like I said, class as a whole did fairly well. So I'm was reasonably, I say reasonably pleased. I guess I didn't, I wasn't going to lose sleep over it, I suppose. But I mean, it's your grades. But in terms of you learning the material, I felt that the class as a whole did well, which is a good sign, because this is usually, I would say these were high scores for the typical midterm. I think that the class average would have been closer to like a 60, and there would have been more people down in that 30, 40 range. So as a whole, the class did well. Those of you who kind of got lower scores than you wanted or whatever, don't lose hope. Remember, you can still get an A in the class. You can fix whatever crap grade you got in your midterm with what you get on the final. So I'm giving you got plenty of opportunities. But really try to understand what went wrong in the midterm, whether it was just a series of unfortunate mistakes you made on every single question, where you just got 6 or 7 out of 10 on like everything because you kept making mistakes. Maybe that's test anxiety, whatever. I get it. Or you're not putting in the time and the homework, or you're getting too much help from other people and not processing the stuff yourself. Just be honest with yourself. If you really question whether or not this is for you, feel free to set up a time with me. I'm happy to sit down and I'll be honest with you. But generally speaking, outside of the person who just decided not to take the exam, I would maybe encourage all of you to stick with it. It's not uncommon to still suck pretty bad at this point. Okie dokie. So let's go back to what we were looking at right before break. I think we had just done some stuff with random numbers, right? And I was getting ready to do like a dice rollery type flippy. All right, so let's get my random number stuff back in, because this machine went bouncing across a highway. No, well, medium traffic road. Let's call it the other day. So there was some rebooting that was not expected. So here, just let me, the who? Yeah, the so all everything red here is it came as a kit, which I'll tell you what, I especially suck at doing with. No, it was the screen protector. Oh my gosh, I am incompetent. I had this thing like on sideways basically, and I'm barely exaggerating. Just really, it was bad. I had to have my wife come over and and she's sick, so like, and she did a much better job than I can. She's been doing unofficial jury duty. I don't know if you've been following the court case, the Darrell Brooks guy and Wauwatosa. I think it was last Christmas. He ran over a bunch of people with a van and killed people, and I mean, he was bad. But it's a public thing, and he's defending himself, so it's pretty good entertainment for about 5 minutes. But then it becomes annoying. Well, she's like decided she's like a juror. She's taking breaks with coming back, and she's enamored with the whole case. So that's how she's been spending her time. So I did interrupt jury duty for her to help me do this. All right, so let me just dump. Actually, you know what? Let me hide floating that guy, right? Let me just start a fresh project here. I don't remember and we selected this dude, right? Just a normal C++. No, this would be good. I'll just remind us real quick what the thing we saw here was. Leave that off for a second. All right, so I'm including standard lib.h, which is where the random number generator function lives. Remember our standard IO. Actually, standard IO is not what we used here. We use IO stream. So our cout stuff lives inside of IO stream. Standard lib is srand, although I thought we saw that these guys already existed. I'm just going to test this real quick. Yeah, it does. So you don't need the, this is enough to accomplish what we're doing now. In fact, you don't even need the time part yet. So what I do here is I'm going to go ahead and do something 10 times. What am I doing? I'm going to write something out to the screen. I'm going to generate a random number just so you can see what this guy does. A random number gives you a number in the range of integers. I think we saw that it's only positive integers, right? Yeah. So then my guess would be it's going to give you a number between 0 and 4 billion, 4.2 billion, using the entire 32-bit space for an integer. But let's call it the range of positive integers. These are all giant numbers. If I wanted to give me a smaller range, I could take whatever that number is, divide it by 10, recording the remainder. Possible remainders for dividing something by 10 are 0 to 9. Add 1 to it, so now this will generate a bunch of numbers between 1 and 10. All right, so there's a bunch of my numbers between 1 and 10. Pay attention to these last 3 numbers here, 3, 10, 2. 3, 10, 2. Well, it wasn't just weird luck, right? 3, 10, 2. So the default random number generator RAN that we're using here, and there's other libraries that have random number generators that might be better or whatever. This is just kind of your traditional one. It uses a default, what's called a seed value for getting true randomness. So what we can do is we can bring in the time library and we can seed our random number generator. There's a function called srand that's built into this. And we can seed it with the current time in milliseconds, which then gives us different values every single time we run it. So 533, 187, yada, yada, yada. All right. So if you need to do random numbers, your 1-2 punch would be seed it one time. That mixes it up, if you will, shuffles the deck for this particular run of the program. And then whenever you want a random number, this guy will give you a random number in the range of all positive integers. And then if you need to whittle it down to something smaller, you can use modulus along with addition if you need to move it into a range to accomplish that. All right, questions about random number generator stuff? And actually, doing something like this, if you're testing your code, it actually can somewhat be nice if you're always getting the same random number generator, same numbers generated for testing purposes, because if you're getting the wrong result, at least you can fix it up and then test it against the exact same outputs. And then randomize it more when you're done. So if you needed to do some testing, you could just comment that part out, and now it won't, so there's your 310.2, 310.2, yada, yada, yada. Good. It's a default input for time. So the time function can take in a number, which is like, I think it acts as an offset to the current time. If you pass in null, it means nothing. So it says, give me the current time in milliseconds. So I would say the best answer to your question is this is just what input you give it to make time give you the current time in milliseconds. Null means nothingness. We'll see other examples of null eventually, but this word means nothing. Literally nothing. We're passing in emptiness into the function. All right, other questions? Some programming languages use nil, N-I-L, instead of null. Other languages use null in all lowercase. Java's N-U-L-L, all lowercase. Objective-C is nil. Swift is, I think, the bunny emoji. There's a greater than 0% chance that it's what I just said is true, which is scary. All right. So now we have this tool, random number generator, and we decide, okay, well, what can I do with this? Well, I suggested, hey, maybe we do a random number generator or do a dice roller for like Dungeons and Dragons or something like that. So we think about that. So when you play Dungeons and Dragons, you know, we have something called you know, the D20 dice. So you get these dice sets. Something looks like this. Nobody uses a D20 that looks like that. If you're playing Dungeons and Dragons with somebody who brings a D20 that looks like that, run. That guy cooks hair in his spare time. All right. So, man, I've never seen that. I've seen D3s. Nobody uses a D3, but a D3 dice kind of looks like this, where it's got like a weird twist thing, but whatever. So your common D20 looks like this. It's a 20-sided die. You roll it, you get some value between 1 and 20. Now, the dice or the dies that we've been used to our whole life are the D6s, right? These guys, you know, yeah, like Yahtzee uses those, and you know, the whole rigmarole. So this is a D4. A D4 is a 4-sided die, 1 through 4. D6, D8s, D10s, D12s, D20s. Those are your common dice, let's say, if you're playing like Dungeons and Dragons or something like that. Is there another funny one I missed?
They replaced zero.
Oh, did they? Is it a bad word?
Well, it's not in there.
Yeah.
Different thing.
Oh, which one am I? Oh, is it like oh. We won't bring attention to it. That is Google's fault. Apparently, I don't have the child safety search on. So anyways, well, we'll just hit backspace on that, which now it's more front and center, actually. We'll just go like that. I maybe had said this in class one time, and this is related to random number generators. We wrote a program that just randomly generated 6-character words, 4-character words, something like that. I don't remember. Now I'm forgetting which bad word it was, but it was one of the bad words. I think it was the F word. But it randomly generated it. Like on like our third roll, like our third, right there in the middle of the screen. And you know, it's like haha funny. Everybody found it funny. It was, what are the odds? All right. So in any case, we want to try to create a program that allows us to roll a D20, roll a D8, something like that. Okay. So maybe we write a function that returns an int. Maybe we call this guy roll D20. takes no parameters. And I'll go ahead and prototype them at the top and write it at the bottom. Just it kind of keeps our cadence of kind of documenting your code up top and then writing the ugly details later on. Oh, what am I doing? What is going on? I have control. All right, so I'm just gonna elevate that guy a little bit. Now, I only need to randomize my random number generator with time one time for a program. All right, so in this particular program, remember all programs begin and end with main. So right at the beginning of main, I go ahead and do an srand on time. This is going to give me random numbers for the rest of this program. Okay. You can think of it like at the casino where they shuffle the deck, right? But I think I mentioned last class that true sources of randomness are actually difficult, and that even includes like games of chance, like in casinos. That's why I think I'm not really a gambler, but I'm pretty sure they use multiple decks at casinos, 4 and 6 decks and stuff like that, to fight against like folks who count cards. I think I've seen them counting card movies. I've seen those guys. And apparently the latest cheating scandal is the grandmaster chess guy who was using a foot computer or something. I mean, that's kind of impressive in and of itself. That being able to that's why I think for like some of these sports, rather than doing drug testing and stuff, you should just have a league for that. Wouldn't that be awesome to watch baseball where you just have people with like augmented robotics on their pitching arm? You know, 230-mile-an-hour fastballs. I'd watch that. I mean, at that point, you're not saying who's juicing, right? The guy's got a robot cannon, literally. Right, and it just makes it great. Well, then it's not cheating. It's playing within the rules. Now it's like, who has the right funding? Super baseball. They're moving the fences back 15,000 feet. They're playing out over the ocean. All right. How to get onto ocean base rockets? Cheating. That's it. That's it. Man, sometimes I surprise myself. Huh? All right. So, anyways, if you want to get truly random, pseudo-random numbers in your program, this won't be a perfect source of randomness statistically, but it should be close. You only need to do this guy once. He shuffles your collection of numbers, and then from this point forward, you have randomness in your code. All right. So you don't need to throw this inside of every one of your functions. All right. So if I call the function roll d20, what I want, and I'll just put a little comment before this guy, this returns a value between 1 and 20. Like we rolled a d20. Okay, so this guy should return what? What can I put in here to return a value between some random number between 1 and 20? Go ahead. Okay, so rand mod 20. Well, I'll put a space there. All right, so this guy is going to give us some number between what? 0 and 19. So whenever we take something and divide it by a number and look at the remainder, the biggest remainder you can have is whatever number you divided by minus 1. Otherwise, the number went into it an additional time, right? So 20 divided by 2 is not 1 remainder 10. It's 2. It's what number did I say? Hold on, just so I can give you the right example. I said 20 divided by 2. 20 divided by 2 is 2 goes into 20 10 times with a remainder of 0. So we don't say it goes in 9 times with a remainder of 10. Make sense? If it gets back up to the number, we have a full remainder. So we say rand mod 20. This gives us a number between 0 and 19. Then we want to add a 1 to that to give us a number between 1 and 20. So that's what our roll d20 should give us here. So if I want to roll the d20 a couple of times, so we'll just say for int I is equal to 0, I is less than 10, I plus plus. And we can do something like C out. Well, actually, let me ask you this. What would the output of this program be? So read the code. Everybody take 30, 40 seconds to read the code and tell me what the output of this program is going to be. I'll come to you in a second. All right, what is it? Okay, well, I did return something.
No, you were close.
You're still right. Go ahead. But what am I going to see on the screen? So this code's going to show me 20 random numbers. Okay. No. Go ahead. Yeah, you. This dude right here will boil down to a number between 1 and 20, 10 different times. But I'm not doing anything with that value. I get it has a value. This guy will be like a 6, right? It will turn into a number, but I'm not doing anything with that number. It's never getting spit out to the screen or anything. So the actual output of this program is going to be nothing. The program did a bunch of stuff. It rolled the dice 10 times, but I didn't do anything with those values. So if I go and run this right now, we get nothing as our output. If I do a C out on whatever that guy boiled down to, now I'm going to get 10 rolls of my D20. Now, if I need to use that roll, so for instance, what happens if I want to ask a question about so if we're thinking about a game like Dungeons and Dragons, we might roll the dice. Okay. That's when you're supposed to wake up.
That's my alarm to ask you a question after class. I forgot class and got all of them.
Oh.
Okay. So I put my Spanish class in high for.
Oh, I see. Well, is it like an in-class type question? Or okay. So try to remember to ask me after class. All right. So if I'm playing Dungeons and Dragons and I'm getting ready to attack you, I might take the D20, I might roll it to find out whether I'm able to hit you, right? It's an attack roll. Okay. And he has a certain armor class and stuff. So he's kind of hard to hit. He's blocking stuff with his basketball and all that stuff. But he's a little slower right now with whatever's going on with his leg. So he doesn't have real great lateral movement. Okay. But I roll my D20 and maybe anything above a 12 hits. Okay. So I might ask the question, well, if I rolled if what I rolled was greater than or equal to 12, it's a hit, then I maybe roll the damage for my short sword or whatever weapon I'm using. All right. But in Dungeons and Dragons, sometimes we have like critical hits and we have critical misses. So if you roll a 20, okay, that means he's got it coming. He's got it coming. That's going to be some extra oomph. Okay. But if I roll a 1, that means like I tripped over my own sword and ended up like cutting my own leg or something like that. So like you can imagine how epic tabletop role-playing games could get.
Yeah.
Right? You're sitting there with your tang, and you're Ritz crack. You know, you told mom to leave you alone, you know, but you're 30. All right, so if we want to ask some questions about how we rolled here, how would I do that? If I want to ask a question about what the roll was, I rolled right here. Go ahead. Okay, so right now, yes, I got my roll here, right? But I've now burned past it. If I want to ask a question about how I rolled, I no longer have that value. I printed it, but I didn't put it anywhere. So if I need to remember that value, I could say something like the roll is equal to this dude right here. So I can remember what I just rolled. Then if I want to display what I rolled, that's fine. But now I can ask some questions about it. I can say, if the roll is equivalent to 1, maybe we print out you know, epic fail, something like that. Else if the roll is equal to 20, epic hit. Else if the roll is greater than or equal to, I use the example, what, 12?
Yeah.
Greater or equal to 12. If we print out normal hit incoming. Else you missed me.
You
You're missing me. You missing me? He's very excited. You missing me? All right. All right. So now since we stored the roll, we have the ability to ask them questions about what went down. Go ahead.
Is that gonna throw an error?
It won't throw an error. I would maybe make an argument that good programming practice would be to say int the roll, maybe here, then set it equal to something in here. Define it once, use it multiple times, but it wouldn't be an error since this guy is its own scope. It would let you do it and probably optimize it out in the compiler. But it's a good question. He was asking, if I define it here, it's getting redefined every single time through this loop. It will allow it, and we are getting a brand new number each time through the loop anyway, so we're not overwriting it. But I would say good programming practice would look like this. Define it beforehand, use it in here. Go ahead. Somebody had their hand up back there. Oh, okay. All right, so let's see how we did. So we got normal hits. You missing me? Oh, epic fail.
That's unfortunate. Rolling 290.
Any of you ever played like tabletop Dungeons and Dragons or anything?
Yeah.
One night.
I love my Legion Eva, so Gary comes there. That's really the big tabletop.
Okay. Yep. If
It's
you
finally you play with friends and he goes freeze and then like it echoes through the room and all the enemies turn around and
Oh.
like, why did you say
if you go back in time there before Dungeons and Dragons, well, actually in the early days of the original Dungeons and Dragons, there was a game called Roll Master that had like, I don't know, 40 different books. Like it was like the super detailed version, like the tabletop role-playing game you've been training your whole life for. Like epic fails, you'd have to roll another dice to see like which epic fail table you would roll on. You know, there was like a horn tusk table, but you had like maybe 8-9 books filled with different kinds of fumble tables. Way too much detail, but it was.
You can learn like you can teach a class.
Oh, easily, easily.
You play it? Or-
Oh yeah, yeah. Those were. Well, yeah, because then you could take advantage of it. Because the whole point of like tabletop role playing is not to necessarily win. It's like that I would always like be in character. So I one time played this wizard that refused to use magic, which made him extremely invaluable, of course. So he had a stick, so he kept rolling on the horn tusk table to like do damage. So at best he would do like one damage. Well, one time he took a hard hit to the head, and then he became like epic wizard. Started using it by accident. It was
Okay.
I like getting into character. We had a murder mystery thing at my country club last week, and I was cast as one of the mafia families. So this was like from the 1920s. So um yeah, I won best actor. All right. So we can do things like this with our D20. All right. We can have other functions for rolling a D8, a D6, whatever. We can have a generic roll function. So we can say int roll, and maybe this guy takes in a number of sides. All right. Then when we write this, how would this roll if it's good for a D20, we'd call roll with a 20 in here. For a D6, we'd call roll with a 6 in here. How would we modify this or modify this? To work generically. Go ahead. Yep. So we'd replace this hard-coded 20 with however many sides they passed in. Like that. Okay. So now I can replace this guy with a roll 20, and we're rolling a D20 every single time. So we get the same type of thing. If I want to roll a D200, so on and so forth. If we want to roll a D3, you're going to get a lot of critical misses probably. Because our possible outputs were just 1, 2, or 3. Okay, so we kind of get how this might work. All right. So now what we want to do is we want to, continue our idea of creating a little Dungeons and Dragons type game using old procedural programming. Where we're angling towards here is we're going to see this get a little bit not complicated in terms of the type of code, but it's going to start becoming kind of spaghetti-ish code where we just have a lot of stuff floating around. Okay. But we want to actually let's just call this, not quite Dungeons and Dragons since we don't have a full whatever. We'll call this guy Deathmatch. All right. So Deathmatch has 2 players. A player has a random number of hit points between 10 and 25, let's say. Okay, hit points is like how much damage you can take before you die. All right, so you have 25 hit points. They gotta hit you for 25 before you lose. Okay, a player has a random defense. Yeah, well, this is armor class. There's a random armor class between 8 and 16. Say something like that. A player does random damage between 2 and 6, something like that. So they're swinging a baseball bat. They might just kind of barely get you and hit you for 2, or they might really crack you. All right. All right. So the game has players flipping a coin to see who goes first. And the first player rolls a d20. Let's just actually start this at a new thing underneath it. First player rolls a d20, and if it is at least as high as the opponent's armor class, it is a hit. A hit then requires a damage roll. Notice a random damage between 2 and 6, where the amount of damage is subtracted from the opponent's hit points. A player dies when their hit points reach 0 or less. Something like that. We won't deal with critical hits and critical misses or anything in this one. All right. So if you and I were doing this, we'd flip a coin to decide who goes first. Okay. And obviously I'm using a weighted coin where it's heads on both sides. So I go first. So then I'm going to roll my d20. You know, he already has his stats. So if we kind of take an example of this. We're going to have player 1. Let's see, what were the range of hit points? Hit points were 10 to 25. So we'll say player 1 has HP is equal to 17. Oh. And let's do player 2 while we're at it here. Player 2 has HP equal to 20. Player has a random armor class between 8 and 16. So we're going to say that this guy has AC of 12. This guy has AC of 9. All right. Now, again, these were randomly generated. I'm just kind of giving you an example of, hey, we have 2 players. We've randomly figured out his hit points, randomly figured out his armor class. Keep going with the example. We got to figure out how much damage that player does. Now, the damage is done on each swing, some number between 2 and 6. So you don't have a player that just does 4 damage every time. So we will calculate the damage whenever they actually go and hit. All right, so these are our couple of players. So if I drag this over here. All right, and let's assume player 1 goes first. So we'll say something like player 1 rolls a, now he needs to roll at least a 9 in order to hit player 2. Rolls at 11, which is greater than or equal to 9. So this guy rolls an 11. 11 is at least as big as this dude's armor class. So he will hit player 2. He rolls a value between 2 and 6. So let's say he gets a 4. So 4 is subtracted from player 1's HP, leaving them with 17 minus 4, 13. 13 hit points. Oh yeah, player 2. So this is 16, right? Player 1 hit player 2. So player 2 takes damage, their hit points 20 minus the 4 is 16. All right. Then we might ask, are they dead? Is player 2 dead? No. 16 is greater than 0. They don't have less than or equal to 0 hit points left. Go ahead.
So I'm like a little confused. So you got the auto class, right? If you're rolling 11, you only get rid of your armor.
No, their armors always stays the same. It's just that's how hard they are to hit. Is their armor class. So this will always be a 9 for player 2 after we've generated it once. Correct. Yeah. So if player 1 rolls a 7, that means they did not hit player 2 because that was not at least a 9. They don't get to roll damage. They don't get to change their hit points. Now it's the other guy's turn. All right. So he's not dead. So now we're going to say player 2 rolls, and we'll have this as an example. Rolls a 4, which is not at least as high as a 12. So they miss and their turn is over. Keep going until someone dies and announce the winner. Make sense? Homework. Create a program that simulates a single fight as described in the previous 2 slides. And show the progress as the fight goes on. So you make sure you are doing the math correctly. That is to say, show each player's hit points after each round of fighting. Sure. Yeah, just make sure you're getting feedback so you know that you're subtracting correctly, that kind of stuff. All right, and this is due on Thursday. And I will give you this code. So let me save this. Call this guy Deathmatch. I'll share it. So I'll give you this as a starting point because you're going to use our random number generator multiple times in different ways to get these numbers, right? All right. I will see everybody on Thursday.